TNT Gaming here from ForkInTheWall, and today I am joined by my friend, and we are going to be talking about
You just ruined my day.
stars and black holes and dark matter we're going to be talking about. This is the first. Hey, it's me back again. That was good God. Okay. Anyway, we're gonna be talking about how stars work right now, and Jacob has drawn us a lovely diagram that is probably going to be zoomed in on right now, and I don't think you'll be able to see my face. Anyway, so Jacob, can you please explain this diagram to him?
Those noobs out there who don't understand.
Yes.
Okay, it takes 4 hydrogen atoms to make 1 helium in a star. When they fuse together, there are 2 hydrogen atoms that are lost in the fusion, which, by E equals mc squared, means matter times the speed of light squared equals energy.
I thought it was matter times the speed of light squared, that the fraction of the speed of light squared.
It's the mass by gram.
It's the mass times the fraction of the speed of light that it is going. So, like, if it's going the fraction of the speed of light that it is going squared. So if it's 1/2 the speed of light, it's 1/2 of the speed of light times 2. Times whatever that.
Squared.
Squared, yeah. You said it was just speed of light.
What
It's not.
No, it is.
No.
So either way, this is a very important equation. Remember it. 4
Yes.
hydrogen atoms makes 1 helium. This makes a huge
Impact on what we're going to talk about. Stop button. So we're back, and remember that little equation that we showed you earlier? 4 hydrogen atoms is a perfect fusion. Well, if you add something else, that
oxygen and carbon
oxygen and carbon
makes a little friend that I call iron. You used it in your pot today, chances are, to make your breakfast, your eggs. You're just going to eat it. Like, this is lovely iron, but you're a horrible person.
Because iron can destroy suns. Well, not
Stars.
just suns. It can destroy Sol. It can destroy Kepler 23.
Stars.
Yeah. Well, no, not really, because they didn't chuck it up. Let's just see what happens if you chuck a pound of iron at the sun. Well, probably
I dare
not.
you.
Yeah.
Now you're going to kill us all tomorrow.
Well,
Good for you.
It probably wouldn't get there.
Probably
Anyway,
wouldn't.
if an iron atom, it's got to be a couple of pounds, or no pounds.
No, it could be an atom.
Well, if something if any iron molecules reach, well, not if it's nano iron. Anyway, if any non-nano iron reaches the sun, or any star, Sol included, it will explode.
Either in supernova or hypernova. Most likely it's going to be supernova.
Yeah, most likely. Supernovas.
Hypernovas are just too OP.
Yeah, they're too strong.
Don't do it. Don't go do it.
Yeah. Even if you shot a bullet, it would never make it. It would just stay in one place. Because of the expansion of the universe, which we are going to be talking about a bit later. I'm not sure if Jacob's done.
Probably not.
Okay, so we're back with black holes and quasars. I hope I'm not blocking the image. So, Jacob, do you want to explain what I've drawn here?
Really bad drawing of what you seem to have spelled a quasar.
Yeah.
A really bad drawing.
Yeah, really.
Really bad. Don't do that.
Hey,
That's
it was quick. Okay. Yeah, it should probably look more like this. Like those fans should probably look more like.
We're not giving art lesson to Sherlock Holmes.
Okay, they should probably look more like that.
We are.
Anyway, so when a star collapses in upon itself, if it does, it turns into a black hole. Now, if you don't know what a black hole is, if you've seen like Star Trek and stuff, you'll think that it's like a portal to another dimension or something.
That's a theory, but we can't prove it. Yeah, are you really going to go drive into a star? Alternate dimension.
I just got spaghettified. I know where you went. Spaghetti land. Anyway, so once a star collapses, it becomes really tiny. Imagine this: if you put the Earth into a stone, like a pebble,
a marble size,
like a marble size, that would be like the scale of a black hole, except it's like Jupiter. It's like a sun that turns into Jupiter.
No.
Except nothing?
No, it's a sun that turns into more like a Neptune.
Yeah. Well,
That's-
but let's just say that it's got a lot of mass for such a small object.
Oh yeah.
Shut up. I was waiting for you to do that. Anyway, it's got such a large mass for such a small object that it creates a lot of gravity, and it's got so much gravity that it can trap light, matter, and theoretically it can let data go through, but that's just a theory.
We don't really know.
Yeah.
I dare you to test it.
Shoot a laser beam with the transmission on it. Maybe the Martians will pick it up or something.
Well, then again, there'd have to be a black hole between Earth and Mars.
Except I wasn't exactly saying Mars. Well,
You
no,
said the
okay.
Martian. You said the Martian.
Well, you know what? Hey, we'll
The,
read
un-
that.
the
We'll
universe is
read that.
infinite. It's
Okay,
got to
what
be
if
out there
there's two
somewhere.
planets called Mars?
Actually, my theory of what a black hole does is it takes matter from this universe and reassembly, like a white hole would spew it out on another side of another universe.
Well, no, it just.
That's my
yeah,
theory.
in
That's
the
my.
Same universe.
No, it's my
A
theory.
black.
It's my
a
theory,
worm-
Pat
okay,
Paul.
okay, I think you're talking about a wormhole, not a white. Okay, you know. And then when the matter and the when the matter and the light are around the thing, they are usually spinning and also getting eaten up. So when it eats all of its quasar or blazar, depending on which one it is, it's shut up. The black hole gets dead. Yeah,
Get dead.
it gets dead. And it
No, wait. Isn't when a quasar doesn't it have like two like funnels coming out because you can't take out in all that matter? It's
yeah,
somehow.
got it.
I mean, like you're pretty
Two
much just.
dimensional drawing, goddammit.
So there's pretty much just like a funnel cloud just like coming out of both ends because like I mean, would you really eat 500 Earths per second?
Yeah, no,
You would spew some of it out probably.
that would make them have to lay off the terrestrial planets.
Oh man, that'd suck. Gotta
They have nachos, man.
So are we going to get into hypernovas?
And
yeah.
stop it. Stop it. Stop it.
So
We're back.
the mass of our sun is like tiny compared to other stars.
The math, not our math.
I said mass.
I mean, we got a lot of math here on this,
Yeah. So the mass of our sun is compared to other stars such as like Proxima Centauri is kind of sort of extremely small.
Or Kepler 22.
Kepler 22.
Kepler 22 is really big.
Yeah, it is. What's the biggest star that we know about now?
I think it's in the Andromeda Galaxy.
Well, probably. Yeah, the mass of our sun is considered
Small.
small.
World, they usually put tiny because it's pretty small.
That's on relative comparison. Now, but multiply that by, I believe, 500, right, Russell?
Mm-hmm.
And you
Well,
can have
512.
what?
512. That's just more
512
exact.
would be the minimal requirement to have hypernova. I'm not going to write that. I'm too bored.
Yeah.
I don't have
whatever.
time to do that.
Anybody got time for a hypernova?
All right. So either way, a hypernova, big sun or star, sorry, whatever.
It goes boom.
Go. And like as our little friend Fe shows back up. He likes to destroy stars.
Yay, sun!
Hold on, let me see if I can. Ah,
You're in the way.
no, not. Like, whatever. It's the light. You can't see Fe.
Well, then why don't you erase it, everything and write Fe again? Or you could just write Arun as in Latin.
Either way, Fe. Our little friend shows up again in that big star that we were talking about. 500 times the mass of Earth. No, sun, whatever. You know what I mean.
500 times. That's not even as big as the sun,
I
dude.
know, right?
I'm just
I'm
gonna.
tired today.
Okay.
Don't judge.
I'm
So
judging.
either way, little friend Iron shows up. He goes da 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 da. I'm gonna suck up all his energy, and you're going to die.
That's nice.
Right?
He's kind of like my mom. Anyway,
And he decides that, oh, radiation, you're not winning against gravity anymore. I'm just going to crush this entire thing. And this is how our little friend, the black hole, shows up. See, all these people are just showing up to this party. Isn't this wonderful? everything coincides.
Coincides. You'll figure out what that means later.
No, we're not stopping yet.
I know.
So either way, our little friend Effie shows up. He destroys the star, becomes a black hole. Now, there's still a lot of mass left over from the star.
And radiation.
And this forms a little quasar. And this starts spewing out little chunks of the star, like a little baby who isn't happy. Hint, hint, him.
That is me, just kidding.
Okay, anyways. It forms what we like to call... Guess, I dare you.
It forms a planet.
No.
It forms an asteroid.
No.
It forms a comet.
No.
It forms a super complicated thing that I can't think of a made-up name to call.
Isn't that everything in the universe?
Pretty much.
And so we just give it a number. So either way, it
One.
forms a gamma
It forms
pulse.
one.
It forms a gamma pulse.
Yay.
And this is kind of like, oh, say, a supernova. Our star just went supernova, pretty much, and we're not going to survive. Let's say a gamma pulse hits us. Oh yeah, Earth's not going to last very long.
2 seconds? I'll give it that.
Tops.
Tops.
We're not very good at surviving. The tardigrade now, on the other hand.
That's for a later video, Jacob. Why did you tell them that? That is really mean.
Duh.
Okay,
You're recording.
that's dark matter.
Artist conception. We have no idea what it looks like.
I can't find a pun for that. Anyway, so let me try to draw this better. It's supposed to look somewhat like this, but while I'm drawing it, I'll explain to you what it is. Dark matter is essentially...
Draw it a little bit lower. It's conception of the computer.
Okay, dark
Lower
matter
than that.
is... What?
See.
Lower, oh, okay, I thought you said bigger. Okay, dark matter is the stuff that keeps you and I from exploding. Yeah.
And also inside the galaxy.
Yay! And also the universe, and also the dimension.
If we didn't have that, we would be, I don't know, like somewhere
We
else.
wouldn't even exist.
You owe this sucker so much.
We really do. So this is what a dark matter atom. They're not really atoms. There's something else. I forgot the name. We don't really have a term. It's like a number or something. I don't know. Okay.
Isn't that everything?
Yes, it's everything.
It's like,
I wonder what number Earth is.
like probably,
1. That would
no,
make
no,
sense.
actually it would be like more like 3 because we're the 3rd planet out.
Except for the first thing that everybody knew. Anyway.
Okay.
So essentially what dark matter is, well, we don't know. So we decide to call it sometimes exotic material. Oh no, wait, that's negative energy. We decide to call it
Exotic matter.
no, that is
Negative energy?
energies.
Okay, I'm
It's
sorry.
dark matter. We decided to call it dark energy sometimes, dark matter, dark energy, whatever you want to call it. It's the same thing. You'll see it written that way. And there's a theory with dark energy that we could create stuff with it, but dark matter, like,
We have no idea.
yeah, we have no idea what it is. Dark energy is just a thing that makes scientists cope.
Can I ask a question, Professor Russell?
Yes, student Jacob.
So let's say all the dark matter in the universe just someone decided to flip a switch and it became
Or it's in
matter.
a parallel universe. And
Let's say
it's
it
not
just
there.
became matter just spontaneously.
Well, what would happen would be, it would take time, like
No, let's just say it spontaneously just turned to matter.
I'm talking, like, yeah. It would take time for anything really to happen, like 1,000 years. The galaxy would just start to spin itself apart. We would go like 50 years after that happened, because it would spin us off of the...
Like a frisbee.
Yeah, it would
Like it
throw
would
us. I think we would still live though, because the solar system, like, there's still gravity, so the solar system would stay together, except it would be shot up in space. But there's a chance that Earth might get shot off, and there's also, like, if Earth did get shot off, I don't think the human race would die. I think that actually. I mean, it wouldn't like we wouldn't all die.
Eventually we'd die. I mean, the sun would expand. I mean, nowhere else in the universe to go.
Yeah, there
Just
is.
like-
What if another sun gets there?
Just so
Start orbiting that one. Anyway, so yeah, and if that happened, the galaxies would soon spin themselves apart until their center becomes a big.
It's already a black hole.
Yeah. The black hole would be. It would not be there anymore. It would be like shot off in different directions. But only big things would be ripped apart because they're spinning so fast. And yeah, that's why dark matter is very important. You can stop the clip. It's just that stop button, not the big red one, the white one.
Oh, okay. We are recording now. You're trying to draw a wormhole. It's a
Pretty good drawing.
It's a pretty sucky artist conception. Opinionated, but okay then. It's a wormhole.
Okay, so this is not Newton's dumb. What is it? The
Conception of the atom.
yeah, that one. It's not that. This is negative energy or
Exotic matter.
I can't see my face.
Now you can.
Anyway, so negative energies
Exotic matter.
are we have no idea exactly what they do or what they are. Well, we know what
We have theories.
we know what
Its potential.
we know what
Exotic matter.
does, but we don't know what negative energies do, even though it's the same thing. Again, it's like the black hole thing. It's like a thing that makes scientists. There's still hope. We might find out what it does someday. Anyway, so this is what it looks like, kind of, because I'm a doodler, not an artist. This is the core of it. This is the.
Do you want me to draw it? Because I'm in art class, right?
I was in art class. Anyway, that doesn't matter. Anyway, so essentially what this thing could do, keyword could because we don't know how to use it or harness it or do anything to it, it could either make a time machine or a wormhole. Now, a time machine that we could control would have to be an infinitely long spinning thing, like an
Which is
infinitely
impossible.
long, unless you have the power of the thing of the negative energy.
Exotic matter.
That too. And but we don't know how to do that, so we can't. We'd have to. It would just collapse like within 2 seconds of making it. Anyway, so a wormhole would be created if it wouldn't be as controlled. It would just be there, and we wouldn't know if it actually opened up anywhere else. But it would.
Either delete you.
Yeah, delete you from the presence, like me right-clicking and deleting your face from the editing. Or it would send you to a different time and a different space. Or a different universe. No, just kidding. That's fake. Nothing can send you between universes that we know of.
Can't.
Except for number 365555555222211. Yeah.
Dim numbers.
Stupid. Yeah. That's essentially all there really is to dark. I mean,
Dark matter.
negative energies or.
Exotic matter.
Wow, you're terrible at that. Anyway, so I think you could end the clip now, please.
Okie dokie.